Performing the same computer task 50 times in a row consumes hours of your day. Writing a sequence of commands to execute those tasks in a fraction of a second is the core principle behind automation. Most beginner tutorials focus on printing a single line of static text. Today, we are going to build a dynamic program that can request information, evaluate it, and respond. You don't need to install any heavy development environments to follow along. All you need is a standard terminal window running on any Unix-based operating system. By following a few structural rules, you will write your very first shell script and apply the foundational logic of software engineering in under 6 minutes. Open your terminal window. To start, let's create a new empty file. Type touchscript.sh and hit enter. To add code to this file, you need to open it in a text editor directly inside your terminal. You can use a built-in program like Nano or Vim to do this. Now that the file is open, move to the absolute first line and type the exact sequence !bin/bin/bash. This sequence is called the shebang. As shown here, it acts as a directive that tells your system exactly which interpreter to use to read the code that follows. Without this declaration at the top of your file, the operating system cannot identify how to translate your text file into a running program. Move to the next line and type echo, followed by hello world in double quotation marks. Save the file and exit your text editor. If you try to run this immediately by typing /script.sh, the terminal will return a permission denied error. Unix operating systems prioritize security. By default, they prevent text files from executing as programs to ensure you don't run malicious code by accident. To fix this, you use the command chadmod +x script.sh. This explicitly grants the file the execution rights needed to run. Assigning execution permissions is a mandatory step for any custom tool built in a Unix environment. Let's make this interactive. Reopen your script and delete the hello world line. Use the echo command to ask for a number. Then on the next line, type read num to capture that input. You can also assign data to a variable manually. On a new line, type name equals user. Note that there are no spaces around the equal sign during this assignment. Adding a space here is a common error that will cause the script to fail. Scripts can also fail if a variable is empty or contains unexpected spaces, as the interpreter may struggle to read the resulting string. This pro tip box outlines the standard solution. Always wrap your variables in double quotes to ensure the system reads the input as a single string. Now combine these ideas into a final output line. Echo, hello name, you entered num. Integrating user input with variables allows your script to process different data each time it runs. To make the script react to that data, we need conditional logic. This allows the program to evaluate the user's input and choose between different outcomes. We will implement an if-else statement to determine if the number the user entered is greater than 10. There's a specific formatting rule for conditionals. You must include spaces directly inside the brackets. Start with if, provide the condition, then define the response. Offer an alternative path with elev and finish with fee. This table shows the operators available for your logic. For instance, -gt checks if a number is greater than another, while -lt checks if it is less. Pairing stored variable data with these operators gives the script the ability to make decisions based on the information it receives. Save the script, exit the editor, and run /script.sh in your terminal. When the terminal asks for a number, enter 15. The script evaluates the variable and prints the response for a number greater than 10. Run it again and enter 5. This time, the script follows the alternative logic path you defined in the else block. You've successfully applied variables, user input, and logic, the core mechanics used to control how a program behaves. These concepts are the first step towards using more advanced tools, like loops and text processing commands, to automate complex system operations.